Sound check, sound check, sound check. Sound check, sound check, sound check. Yep, sound is there. Happy days. Put a timer. We'll start when Twitter catches up. So what are we? 28 minutes. Okie dokie. almost time to get going now. Twitter plays catch up. It'll start like at past on the dot, so I'll keep my eye on just in case it starts any sooner. But then we'll get going. Oh, important job of the day first. Hold on. imported job done now. We're live on X as well. So now we can get started with everything. Excuse me. Just getting through something here, then I'll switch over. Right, let's get it cracking. Okay, so here we are. New module, new set of live streams, a new thing to conquer, which is learn Go. That's a big thing in itself, like just 188 lessons, I'm guessing. Followed up by learn HTTP clients in Go, build a Pokédex in Go, learn SQL, build a blog aggregator, learn HTTP servers in Go, learn file servers and CDNs with S3 and CloudFront, learn Docker, learn pub/sub architecture, capstone project, and then so on. And then there's a whole bunch of stuff afterwards that are like deeper ones that I don't know whether we'll get to or not. I think it might be a stretch to sort of complete them by January as well, but if we can get through this list to 23, I consider that a success. 23 modules in 12 months. That'd be pretty good. Anyway, we're overdue. Let's dive into learning Go. So I haven't opened it up. 20 hours of content, 188 addicting lessons. So, we're going to cover a fair whack of stuff. And hopefully, if I'm not too much of a dum-dum, like I have been in some of them, we'll get through this a bit quicker. So, I'm excited about this one. Let's start the course. Okay. So, learn Go for developers. This course assumes you're already familiar with programming fundamentals in at least one other language. I'll move quickly through the basics. For example, I'll explain how functions in Go work, but I'll assume you already know what a function is. If you're brand new to coding, I recommend starting our Python for Beginners course first. What to expect. For most of this course, you'll be writing code in your browser, but we'll occasionally drop into your local machine to use our official CLI tool written in Go, of course, to pass off lessons. We'll be building parts of a make-believe software project, Textio, a SaaS app for sending SMS messages to customers. The assignment. Hold on, sorry, there's one thing that's like off. There we go. Okay, that was just like a little off point. Assignment. Print starting Textio server to the console instead of hello there. Just copy this. Capitalization and punctuation matter. So I'm just going to one-shot it. Pew! Yay! So package import FMT. So not sure what FMT stands for. And then func main, and then fmt.print line. That. Okay, basic variables. How many chapters are there in this? 16. Okay. And in this first one, wowza, it's 25 lessons. Basic variables. So bool is a boolean value, either true or false. String, a sequence of characters. Int, a signed integer. Float 64, a floating point number. By exactly what it sounds like, 8 bits of data. Declaring a variable the sad way. Var my skill issues int, my skill issues equals 42. The first line var my skill issues int defaults the my skills issue variable to its zero value 0. On the next line, 42 overrides the 0 value. We'll talk about a better way to declare variables in the next lesson. Initialize the variables from the print statement to int, float, 64, bool, and string with their 0 respective values. Alright, okay. Initialize them here. So var SMS sending limit is an int. Oops. No, not interface. Var cost per SMS is float 64. Var has permission is a bool, and then var username is a string. So control enter is to run it, control shift and enter is to thingy it. Short variable declaration. So sad variable declaration, goated variable declaration. So my skill issues equals 42. The walrus operator declares a new variable and assigns a value to it in one line. Go can infer that my skill issues is an int because of 42 value. Yay, type inference. When to use the walrus operator? The walrus operator should be used instead of var style declarations, basically anywhere possible. Limitation is that the walrus operator can't be used outside of a function in the global package scope, which we'll talk about later. Type inference is based on a value being assigned, so an int, a float 64, a string, and a bool. So a common use case with Textio is to send a birthday message. So complete the main function. It should print, happy birthday, you are now 21 years old. Create a string variable called message start. Okay, so message start walrus equals with the text happy birthday, you are now. So happy birthday, you are now. And then create an integer variable called age is 21, and then create another variable message end with this text years old. Years old. Provide the fmt.println statement. Print the full message and assemble it. So okay. Okay, just prints them along and joins them together. Cool. Easy peasy. I think I might get a decent streak on this module. Why Go? Go is my favorite programming language by a good margin. Fast and lightweight, easily concurrent. Easy and simple, compiled, statically typed, garbage collected. We'll talk more about the benefits of Go later, but for now, let's whet your appetite with some more code. Assignment, critical bug. Textio users reported that we're billing them for wildly inaccurate amounts. They're supposed to be billed not $0.02 or 2 cents for each text message sent. Without changing any other lines, fix the math bug on line 8. Okay. Comments. Go has 2 styles of comments. So a single line comment, and this is a multi-line comment. Neither of these comments will execute as code. The new intern on the team screwed up their documentation comment. Fix the issue. The next lesson. The compilation process. So computers need machine code. They don't understand English or even Go. We need to convert our high-level Go code into machine language, which is really just a set of instructions that some specific hardware can understand. In your case, your CPU. The Go compiler's job is to take Go code and produce machine code and .exe file on Windows or a standard executable on Linux/Mac. So code. Goes to the compiler and then it creates an executable. Go program structure. We'll go over this all later in more detail, but to state your curiosity, package main lets the Go compiler know that we want this code to compile and run as a standalone program, as opposed to being a library that's imported by other programs. Alright, okay. Let's the compiler know that we want this code to compile and run as a standalone program. Import FNT, so it imports the FNT formatting package from the standard library. It allows you to use FNT. Is that for formatting package, right? Okay. Line package. This is decent. This is way better than Python's like documentation website anyway. It's a little bit nicer. It allows you to use that. Spin to the console. Func main defines the main function, the entry point for a Go program. 2 kinds of errors. Generally speaking, there are 2 kinds of errors in programming. Compilation errors occur when code is compiled. It's generally better to have compilation errors because they'll never accidentally make it to production. You can't ship a program with a compiler error because the resulting executable won't even be created. Runtime errors occur when a program is running. These are generally worse because they can cause your program to crash or behave unexpectedly. While we're in the browser, it can be a bit hard to tell the difference because we run and compile the code at the same time. So the assignment, fix the code. Notice the compilation error. It's due to invalid syntax. So just closing bracket. Fix the compilation error in the code. Yay! Happy days. Fast and compiled. Generally speaking, languages that compile directly to machine code produce programs that are faster than interpreted programs. Go is one of the fastest programming languages, beating JavaScript, Python, and Ruby handily in most benchmarks. However, Go programs don't run quite as fast as its compiled Rust, Zig, and C counterparts. That said, it compiles much faster than they do, which makes the developers' experience super productive. Unfortunately, there are no sword fights on Go teams. The number one programmer excuse for legitimately slacking off. My code's compiling. Hey, get back to work. Compiling. Oh, carry on. Go code generally runs boop, then interpreted languages, and compiles boop, then other compiled languages. Go code generally runs faster than interpreted language and compiles faster than other interpreted languages. Compiled languages. Type sizes. So integers, units, floats, and complex numbers all have type sizes. So signed integers, no decimal. Unsigned integers, whole numbers / no decimal. So uint stands for unsigned integer. Okay, signed decimal numbers. So int A, int 16, int 2, okay. Signed decimal numbers, so float 34, float 64. Complex numbers. A complex number has a real and imaginary part. So complex 64 and complex 128. What's the deal with the sizes? The size 8, 16, 32, 64, 128 represent how many bits in memory will be used to store the variable. The default int and uint type refers to the respective 32 or 64 bit sizes depending on the environment of the user. The standard sizes that should be used unless you have specific performance needs using less memory are int, uint, float 64, complex 128. Converting between types. Some types can be easily converted like this. So a temperature float is 88.26. Temperature int, so then you take int 64 and put that into it. Casting a float to an integer in this way truncates the floating point portion. Assignment. Our Textio customers want to know how long they have had accounts with us. On line 7, create an account age int variable and assign it to the value of account age float truncated to an integer. Line 7, create an account age int. Okay, account age int. Walrus symbol. And then assign it to variable, assign it to the account age float truncated to an integer. So so it's just int and then account age float. Whoops, I spelled account wrong there. Account age int. Okay. Yay. Oops. Happy days. Which type should I use? So, with so many types for what is essentially just a number, developers coming from languages that only have one kind of number type, like JavaScript, may find the choices daunting. Preferred default types. A problem arises when you have uint 16 and the function we're trying to pass it to takes an int. We're forced to write code riddled with type conversions like this. This style of code can be slow and annoying to read. When Go developers stray from the default type for any given type of family, the code can get messy quickly. Unless you have a good performance-related reason, you'll typically want to use the default types. When should I use a more specific type? When you're super concerned about performance and memory usage, that's about it. The only reason to deviate from the defaults is to squeeze out every last bit of performance when you're writing an application that is resource constrained, or in the special case of uint 64, you need an absurd range of unsigned integers. You can read more about this subject here if you like, but it's not required. When should you elect to not use a default type? Yeah. When memory and thingy are the primary concern. Oops. Which type to use is the same thing again. Yep. What does the size of type indicate? Bits. Go is statically typed. Go enforces static typing, meaning variable types are known before the code runs. That means your editor and compiler can display type errors before the code is ever run, making development easier and faster. Contrast this with mostly dynamically typed languages like JavaScript and Python. Dynamic typing often leads to subtle bugs that are hard to detect. The code must be run to catch the syntax and type errors, sometimes in production if you're unlucky. Languages also have strong and weak typing, meaning stricter or weaker type checking rules. So concatenating strings. Two strings can be concatenated with the plus operator, but the compiler will not allow you to concatenate a string variable with an int or a float 64. Assignment. Textio uses basic authentication to log in users. The code on the right has a type error. Change the type of password to a string, but use the same numeric value so that it can be concatenated with the user variable. Okay. Yay! Compiled versus interpreted. You can run a compiled program without the original source code. You don't need the compiler anymore after it's done its job. That's how most video games are distributed. Players don't need to install the correct version of Go to run a PC game. They just download the executable game and run it. So code goes to compiler, creates an executable production environment, e.g. a server. Only the compiled executable runs in production, no compiler needed. Source code copied to production. Interpreter code and interpreter required in production. With interpreted languages like Python and Ruby, the code is interpreted at runtime by a separate program known as the interpreter. Distributing code for users. Distributing code for users to run can be a pain because they need to have an interpreter installed and they need access to the source code. So examples of compiled languages: Go, C, C++, and Rust. Examples of interpreted languages: JavaScript, sometimes JIT compiled, but a similar concept. Python and Ruby. Why Textio is a compiled language. One of the most convenient things about using a compiled language like Go for Textio is that when we deploy our server, we don't need to include any runtime language dependencies like Node or a Python interpreter. We just add the precompiled binary to the server and start it up. Let's have a watch of this video. Oops.
Than interpreted languages. Interpreted languages have better developer experience than compiled languages. Now, this is some stuff that I'm hearing online. Let's actually break it down and talk about the difference between a compiled language and an interpreted language. When we write code, we write it in human readable format, right? Typically in a file, in the case of Go, a .go file, right? Maybe main.go. And this file is going to contain human readable text, right? Go code that we as developers work on. The thing is, your computer's hardware doesn't know what any of that human readable text means. Your computer's CPU only understands binary, right? Just ones and zeros, right? Which at the end of the day is just numbers, right? But it's just numbers and simple operations, things like add and subtract. So we need some process that we can use to convert human readable code to machine code to be executed by the computer's hardware. And that's all that compilation is. Compilation is just the process of taking some human readable code, right? Go code in our instance, and converting it to binary or machine code that our computer can actually understand. So what does this process actually look like? Well, normally, you start by writing your Go program. So say main.go. And you run it through the Go compiler. On your command line, you type go build. And that would produce a new file, which is the executable program. Let's say we were doing a hello world program. It might be hello world.exe. Right? An executable program on your computer. And then you can run that executable directly on your operating system without ever having to use the Go toolchain again. So the great thing is you can take this helloworld.exe program and give it to someone else, and they can run it on their computer without ever having to install the Go toolchain or even know that you used Go to build the program in the first place. This is different than languages like Python, where if you want to run someone's Python code, you have to use the Python interpreter every single time, and you run the source code directly on your machine. It's also worth pointing out that part of the reason that compiling is so much faster at runtime is that we do all of this compiling work up front. So when we go to run the executable, we don't have to do any conversions from human readable text to binary machine code. That's different than how interpreted languages work. With an interpreted language, as we run the program, the interpreter is reading the human code and kind of at runtime converting it to machine code that the CPU can operate on. Not to beat a dead horse, but I want to talk a little bit more about execution speed. So we talked about how Go is generally faster than the interpreted languages, right? Python, JavaScript, Ruby, PHP, and so on. It gets a little interesting when we compare Go to kind of the natively compiled languages, or the languages that compile directly to kind of machine code that runs on your CPU, versus the compiled languages that run on top of a virtual machine. Right? So the two big ones that run on a virtual machine are Java and C#, while some of the compiled or natively compiled languages that you'll be familiar with might be Rust, C, C++. Even though Go is a natively compiled language, a language that compiles directly to machine code like Rust, C, and C++, its execution speed is actually more similar to Java and C# when it comes to its runtime speed, how many computations it can do kind of per second. And we'll talk more about this later, but the primary reason for that is the Go runtime. There's basically a chunk of code that's included in every Go program that manages memory, and that tends to slow down the execution speed. That said, it is worth pointing out that a Go program tends to use much less memory than Java and C# because there isn't a need for experiment.
Good explanation. So to run a compiled program, users need the compiled executable. Blue hair. That'd be interesting. Compiled versus interpreted. So we did this before. Right, yeah. So it's this thing. Which language is interpreted? Python. So same line decorations. So you can declare multiple variables on the same line. So mileage, company, blah blah blah. The above is the same as this. Assignment. At the top of the main function, declare a float called average open rate and a string called display message on the same line. Initialize them to the values of this. So what was it? Average open rate. Average open rate and display message. And it's going to be 0.23, and it's going to be is the average open rate of your messages. Whoops, I did something wrong. Oh, whoopsie, forgot the walrus. Just getting used to that syntax. Pretty straightforward though. Small memory footprint. So Go programs are fairly lightweight. Each program includes a small amount of extra code that's included in the executable binary called Go runtime. One of the purposes of Go runtime is to clean up unused memory at runtime. It includes a garbage collector that automatically frees up memory that's no longer in use. So comparison. As a general rule, Java programs use more memory than comparable Go programs. There are several reasons for this, but one of them is that Java uses a virtual machine to interpret byte code at runtime and typically allocates more on the heap. Just remember what heap is. stack and heap memory. When a program is running, it takes up memory. Sometimes we are not even aware of the memory being allocated. In fact, every time you create a new variable, your program is allocating more memory for you to store that variable. The article focuses on the two kinds of memory, stack and heap. So general memory layout. Stack stores local variables, heap dynamic memory for programmer to allocate. In previous section, we saw functions cannot return pointers. To solve this issue, you can either return by copy or put the value somewhere more permanent in than stack memory. Heap memory is such a place. Unlike stack memory, heap memory is allocated explicitly by programmers, and it won't be deallocated until it's explicitly freed. Okay. So on the other hand, Rust and C programs use slightly less memory than Go because more control is given to the developer to optimize the memory usage of the program. The Go runtime just handles it for us automatically. So idle memory usage, yeah. In the chart above, Dexter Dow, which compares the memory usage of three very simple programs written in Java, Go, and Rust. As you can see, Go and Rust use very little memory compared to Java. And another video.
Go, Java, and Rust all have very different approaches to how they manage memory, which can have a huge impact on program performance. And there are two things that we mostly care about here. One is speed, how fast your program can do computations, which is roughly measured in the number of CPU cycles required to get the job done. The other is memory usage, that is, how much memory, usually RAM, the program needs to store its data, or your program's variables, while it does those computations. In languages like C, Rust, or Zig, memory management is effectively manual. You as the developer explicitly allocate memory by writing code that says, hey, this chunk of memory will store this data. And later, your code signals that it's done using that memory so that it can be freed up and used by other programs. In Java, things are different. Java's garbage collected, which means that memory management is automated. In Java, it's handled by the Java Virtual Machine, or JVM. When you run a Java program, you're actually starting up a virtual machine that executes your Java program's compiled bytecode. The JVM is responsible for allocating and freeing memory on the fly as it's needed. But this automation does introduce some overhead, and Java programs often use more memory than equivalent programs or similar programs written in languages like C. Now, Go falls into an interesting middle ground. Like Java, Go's garbage collected, so memory management is automated. But unlike Java, Go does not use a virtual machine. When you compile Go code, you get a single natively compiled binary just like you would with Rust or C. The difference is that this Go binary includes a runtime. It has an extra bundle of code that is compiled into every single Go executable. This runtime is what handles the garbage collection, other features like Go routine schedule. One important aspect of Go's memory management is that it's often able to allocate more data on the stack than a language like Java does. And stack allocations, when possible, are more performant than heap allocations. So as a very generic rule of thumb, Go programs tend to use less memory than Java or C# programs, but because Go is still garbage collected, it does tend to use more memory than programs written in C or Rust.
Yep. And at some point you're over-optimizing as well for things. So what's one of the purposes of the Go runtime? To style Go code and make it easy to read, to scare off JavaScript developers, to compile Go code, to clean up unused memory. Bingo. Constants. Constants are declared with the const keyword. They can't use the walrus short declaration. Okay. Constants can be primitive types like strings, integers, booleans, and floats. They cannot be more complex types like slices, maps, and structs, which types we'll explain later. As the name implies, the value of a constant can't be changed after it's declared. Use two separate constants. So something weird is happening in this code. What should be happening is that we create two separate constants: premium plan name and basic plan name. Right now it looks like we're trying to overwrite one of them. Assignment: complete the code to read the bug and create the constant basic plan name. So I guess const Easy McSqueezy. Computer constants. Constants must be known at compile time. They are usually declared with a static value. However, constants can be computed as long as the computation can happen at compile time. For example, this is valid. So first name Lane, last name Wagner. Const's full name is first name plus space and then last name. That said, you cannot declare a constant that can only be computed at runtime like you can in JavaScript. This breaks. So the current time can only be known when the program is running. Current time now. Assignment. Keeping track of the time in a message sending application is critical. Imagine getting an appointment reminder an hour after your doctor's visit. Complete the code using a computed constant to print the number of seconds in an hour. So seconds in an hour is seconds in seconds in a minute times seconds in an hour. Hold on. Seconds in a minute, seconds in an hour times by seconds in a minute times by minutes in an hour. Seconds in a minute times by minutes in an hour. Yay! Just go back to that second. It's just something I wanted to. Can't declare constant and then. Yeah. Okay. Comparing Go's speed. Go is generally faster and more lightweight than interpreted or VM-powered languages like Python, JavaScript, Ruby, PHP, Ruby, and Java. However, in terms of execution speed, Go does lag behind some of the compiled languages like C, C++, and Rust. Go is a bit slower, mostly due to its automated memory management, also known as the Go runtime. Slightly slower speed is the price that we pay for memory safety and simple syntax. Textio is an amazing candidate for a Go project. We'll be able to quickly process large amounts of text, all while using a language that is safe and simple to write. Warning: opinions involved. Does Go generally execute faster than Rust? No. So formatting strings in Go. Go follows the printf tradition from the C language. In my opinion, string formatting / interpolation in Go is less elegant than Python's F strings, unfortunately. So FNT printf prints a formatted string to the standard out. So standard out. Confused about standard in, standard out, standard out. So standard input is this is the file handle that your process reads to get the information. Standard output, your process writes conventional output to this file handle. Standard error output, your process writes diagnostic output to this file. Returns a formatted string. These following formatting verbs work in the formatting functions above. So the %v variant prints the Go statement, the Go syntax representation of a value. It's a nice default. Okay. So I am 10 years old. I am way too many years old. %v. Okay. If you want to print in a more specific way, you can use the following formatting verbs. So %s for a string, %d for an integer, %f for a float, and percentage in the 0.2. The 0.2 rounds the number to the 2 decimal places. So %.2f. If you're interested in all the formatting options, you can look at the FNT packages docs. Assignment: create a new variable called message on line 9 and use the appropriate formatting function to return a string that contains the following. So I guess message walrus equals fmt dot sprint f. Okay, so sprint f. Sprint f formats according to a format specifier and returns the resulting string. Just wondering why the name sprintf. So it's going to be name, open rate, then I guess can I do \n like that? So percentage string, percentage percentage value like that. Yep. Characters output is only a few characters off. Replace open rate, so like replace name with name, replace open rate with the variable open rate, rounded to the nearest tenths place. The word percent should appear as part of the string following the open rate value. Replace new line with the \n, escaping sequence. The only part I'm not sure about is that like. Go print new line. What am I missing from that? I saw Goodman, your open rate is 30.5%. Oh, okay. Just like 1 decimal point instead of 2. So runes and string encoding. So in many programming languages, a character is a single byte. Using ASCII2 encoding, the standard for the C programming language, we can represent 128 characters with 7 bits. Let me read that again. In many programming languages, a character is a single byte. Using ASCII2 encoding, the standard for the C programming language, we can represent 128 characters with 7 bits. This is enough for the English alphabet, numbers, and some special characters. In Go, strings are just sequences of bytes. They can hold arbitrary data. However, Go also has a special type, rune, which is an alias for an int32. This means that a rune is a 32-bit integer, which is large enough to hold any Unicode code point. Let me just let that sink in for a second. In Go, strings are just sequences of bytes. They can hold arbitrary data. However, Go also has a special type rune, which is an alias for int32. This means that a rune is a 32-bit integer, which is large enough to hold any Unicode code point. When you're working with strings, you need to be aware of the encoding bytes to representation. Go uses UTF-8 encoding, which is a variable length encoding. What does this mean? There are 2 main takeaways. When you need to work with individual characters in a string, you should use the rune type. It breaks strings up into their individual characters, which can be more than 1 byte long. We can include a wide variety of Unicode characters in our strings, such as emojis and Chinese characters, and Go will handle them just fine. Assignment. Boots is a bear, not a dog, haters. Run the code as is. Notice that the simple string boots has 5 bytes and 5 runes characters. Update the name variable to be the bear emoji instead of the word boots. Okay. If you got it right, you should notice the emoji is only 1 rune and takes up 4 bytes. Fix more bugs. The code that prints server logs won't even compile. Assignment, fix the bugs. That's a good start. Oh, whoopsie daisy. We like fixing bugs. It's satisfying. Fix types. Someone doesn't know about walruses. Pitiful. Fix bugs on line 6, 7, and 8. Sile to Kaladin. The words Kaladin. You have to speak the words. Type inference. So decimals matter when it comes to inferring types. Assignment. Our current price to send a text message is 2 cents. However, it's likely that in the future the price will be a fraction of a penny. So we need to use a float 64 to store it. Edit the pennies per text declaration so it's inferred by the compiler as a float 64. Pennies by the compiler, float 64 at 0.2 like that. Easy McSqueezy. So format practice. You've been asked to improve the logs to include information about individual users and their recent messages. Create a user log variable on line 15. It should contain all this. On line 15. Where fname, lname, age, message rate is described, the message corresponds to the variables above. Message rate should be rounded to the 10th place. So I guess user log walrus equals fnt dot sprint f, and it's going to be all that. And it's going to be fname, lname, age, message rate, is subscribed, and message. Fname corresponds to the variables above. So fname. So it's going to be percentage string, percentage integer, so just a digit, so message rate, percentage 0.1f, boolean, so I guess, I don't remember what the thing for a boolean was. So T. Message. Yay. Yes, finished chapter 1. We might get through this pretty quick actually. We got 3 nights at this, so I'm thinking if we've got 16 divided by 3, 5. So if I get through, I guess, to chapter 6 tonight, like we could do this maybe like in 3 nights. That'd be crazy. Let's see how far I get anyway. So conditionals. If statements in Go do not use parentheses around the condition, else, if, and else are supported as you might expect. Assignment. Fix the bug on line 12 if message length is less than or equal to message length, then the program should print message sent, else it should print message not sent. So that's the fix. No. if message length is less than or equal to, whoops, sorry, I didn't pay attention fully to the thing. The initial statement of an if block. An if conditional can have an initial statement. The variables created if the initial statement are only defined within the scope of the if body. So if initial statement and then condition. Why would I use this? So it has two valuable purposes. It's a bit shorter. It limits the scope of the initialized variables to the if block. For example, instead of writing length is get length and that, length is greater than that, we can do if length, which is equal to get length that, and then we do length. Okay. In the example above, length isn't available in the parent scope, which is nice because we don't need it there. We won't accidentally use it elsewhere in the function. Why would you use the initial if section? We want to speed up my codes, keep code concise, and keep scope limited, confuse other programmers. Which is valid Go syntax? This one, no parentheses, which I think some people kind of like. Switch. So switch statements are a way to compare a value against multiple options. They're similar to if statements, if-else statements, but are more concise and readable when the number of options is more than 2. Sorry about that, just got something stuck in my nose. So func get creator. Sorry. So they're similar to if-else statements, but are more concise and readable when the number of options is more than 2. So func get creator, it passes OS a string and returns a string. So then var creator is string. Switch the OS if it's Linux, creator is Lionel Torvalds. Windows is Bill Gates. Mac is Steve, and default creator is unknown. Return the creator. So notice in Go that the break statement is not required at the end of the case to stop it from falling through to the next case. The break statement is implicit in Go. If you do want a case to fall through to the next case, you can use the fall through keyword. If you do want I just read that. So all three of these cases will set create to Steve. The default case does what you expect. If the case, it's the case that runs if none of the other cases match. So assignment. I know we haven't covered function syntax in depth yet, but bear with me. Let's see what you did there. Fix the bug in the billing cost function. The basic plan is set correctly, but we need matches for the Pro and Enterprise plans too. If the plan is Pro, the cost should be 20. Enterprise should be 50. So break is implicit. You have a fall through, and then default case does what it says on the tin. Okay, so it says Pro should be, Enterprise should be 50. Okay, so case Enterprise return 50.0 case Pro, then return 20.0. So calculate balance. So we need to calculate the total cost for a batch of messages and update the user's balance if they have enough money. So using the given variables, write conditional statements to calculate and update the variables. So set final cost to the bulk messaging cost. Final cost. So final cost is equal to bulk messaging cost. If the user is a premium user, apply the discount rate to the final cost. So if the user is a premium user, so if is premium user, then user premium user, apply discount rate to the final cost. For example, a discount rate of means the discounted price per message would be, so final cost equals final cost times by the discount rate. We'll see what that comes out with. I don't think it's quite right, but if the user has enough money in their account balance, I'll just run that and see what it does. If the user has enough money in their account balance, if the final cost, if the final cost is greater than the account balance, then deduct final cost from their account balance. Final cost is greater than it's less than, if final cost is less than account balance, then deduct final cost from the account balance. So account balance, I think you can do like minus equals final cost, and then else. And then also fmt dot print print line, and it's going to be purchase successful message, else print the if not, just print the insufficient fund message. So I guess, oops. All right. Nope. So you got 100 bulk message cost. Final cost is the bulk message cost. For the user applies discount rate. Final cost. So example discount rate is 0.1, means the discounted price per message would be 9% of the original. So it would be divided by 100. Means the discounted price per message will be 90% of the original price. Oh, hold on. Maths. Multiply a percentage. Oh, I'm a dummy. So discount rate times what's wrong with that? So set final cost to the bulk message cost. Yeah. If it's a premium user, apply the discount rate to the final cost. If the apply the discount rate to the final cost, for example, blah, blah. If the user has enough money in their account balance, so final cost is less than, I guess, or equal to. Deduct the final cost from their account balance. Print the purchase message successful thing. If not, just print the insufficient message fund message. How do I check it? How do I know like the tests that are being run against it? The final cost minus this amount. I think that's the part that I may be missing. Whoops. Yeah, I'm a dummy. Let's have a look if there was a simpler way of doing it. Oh, they just did it in one swoop. Okay. Yeah, that's fine. Okay, so chapter 3 functions. So what we're saying, we're going to try and get to chapter 6 tonight. Oh, blimey, some of them are a bit long. So let's see how we do. Interfaces errors. Let's see how we do. Functions. Okay, so functions in Go can take 0 or more arguments. To make code easy to read, the variable type comes after the variable name. For example, the following function. Functions Go can take 0 or more arguments. To make code easy to read, the variable type comes after the variable name. For example, xint and stuff, accepts 2 integer parameters and returns another integer. Here is known as the function signature. Assignment: we often will need to manipulate strings in our messaging app. For example, adding some personalization by using a customer's name within a template. The concat function should take 2 strings and smash them together. Fix the function signature of concat to reflect its behavior. So, okay, I guess it's just a string and a string. Lane, happy birthday. Zuck, hope that metaverse thing works out. Go is fantastic. Multiple parameters. So when multiple arguments of the same type and are next to each other in the function signature, the type only needs to be declared after the last argument. Here are some examples like that. Okay, which of the following is the shortest and clearest way to write a valid function signature? This one. Unit test lessons. So, getting into this now, straight away. Up until now, all the coding lessons in this course have been testing you based on your code's console output, what's printed. For example, a lesson might expect your code in conjunction with the code we provide to print something like price 0.2, num message equals 18. If your code prints that exact output, you pass. If it doesn't, you fail. A new type of lesson. So going forward, you'll also encounter a new type of lesson, unit tests. If you've taken a course with us before, you'll know what we're referring to. But in case you haven't, a unit test is just an automated program that tests a small unit of code, usually just a function or two. The editor will have tabs. The main Go file containing your code, and then main_test.go file containing the unit tests. These new unit test style lessons will test your code's functionality rather than its output. Our tests will call functions in your code with different arguments and expect specific return values. If your code returns the correct values, you pass. If it doesn't, you fail. There are 2 reasons for this change. It's more realistic. In the real world, you'll be writing unit tests and running them against your code to make sure it works as expected. You can run and debug your code with fmt.println statements and leave those print statements in when you submit. Unlike the output-based lessons, you won't have to remove your fmt.println statements to pass. Assignment: complete the getMonthlyPrice function. It accepts a tier, a string, as input and returns the monthly price for that tier in pennies. Here are the prices in dollars. Convert the prices from dollars to pennies. If the given tier doesn't match any of the above, return 0 pennies. From dollars to pennies. Convert the prices from dollars to pennies. So we just return the tier. Switch, and then on tier, and say case basic. Whoops. Then return 1, 2. Case. Why is the formatting so off? Like, and then case premium. Return 150, 1, 2. And then case. Why is the formatting terrible? Like, it's not normally this bad. Enterprise. Then, oh, I know there's one dum I made. Return. And then return 500. If the tier doesn't match at any point, return 0 pennies. And then, I guess, so default. Return 0. Yay! Declaration syntax. So developers often wonder why the declaration syntax in Go is different from the traditional established in the C family of languages. So C style syntax. The C language describes types with an expression including the name to be declared and states what type that expression will have. The C language describes types with an expression including the name to be declared. Expression including the name to be declared and states what type that expression will have. The code above declares y is an int. In general, the type goes on the left, the expression on the right. Interestingly, the creators of Go language agreed that the C style of declaring types in signatures gets confusing really fast. Take a look at this nightmare. So Jesus. Go style syntax. So Go's declarations are clear. You just read them left to right like you would in English. So X is an int. Yeah. It's nice for more complex signatures. It makes them easier to read. Yeah, way easier. Reference the following post on GoBlog is a great resource for further reading on declaration syntax. What are we talking about when we discuss declaration syntax? The style of language used to create new variables, types, and functions, the ever important question of types versus bases, the decision about whether to use camel case or snake case, the argument base of, style. Which languages a declaration syntax leads from English left to right? Go. Given the following, what is F? So a function named f that takes an int as an argument and returns an int. A function named f that takes a function as an argument and returns an int. Hold on. This whole thing returns an int. This hold on. So this is a function that returns an int. This is a function that takes takes 2 ints, takes 3 ints and returns an int. A function named f that takes an int as an argument. Nope. A function named f that takes a function as argument and returns an int. A function named f that takes a function and an int as an argument and returns an int. A function named f that takes a function and an int as arguments and returns a function. That one. I'm going to get Boots to explain it because like that is confusing as heck to look at. So gladly encoder, read go types from left to right. So var f declares a variable named f. Function blah 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 is its type. Out of function means a function that returns an int. Its parameters are function int function. So a function taking 2 ints and returning an int. Int as a plain integer. So function f is a function that takes no, it's fine. Don't quiz me anymore. Passing variables via value. So variables in Go are passed by value except for a few data types we haven't covered yet. Pass by value. Variables are passed by means that when a variable is passed into a function, that function receives a copy of the variable. The function is unable to mutate the call's original data. Okay, so assignment: fix the bugs in the monthly bill increase and get bill for month in functions. So monthly bill increase returns the increase in the bill from the previous to the current month. If the bill decreased, it should return a negative number. Fix the bugs in right. Okay, so monthly bill increase returns the increase in the bill from the previous to the current month. If the bill decreased, it should return a negative number. Okay. So what's the problem with this one? So then whoops, walrus. Get bill for month returns the bill for the given month. Cost per second, nums last month and num this month. So all integers are built. It looks like whoever wrote the get bill for month function thought that they would pass in the bill parameter update inside the function and that update would apply in the parent function monthly bill increase. They were wrong. Change the get bill for month function to explicitly return the bill for the given month and be sure to capture that return value properly in the monthly bill increase function. Function signature for get bill month should only take 2 parameters once you're done. Okay, yep, so get rid of that. Get bill for month should only take 2 parameters once you're done. Return the bill for the given month and be sure to There we go. Got it. Huzzah. A little bit of concentration then. So ignoring return values. Got quite a lot to do in this one. Oh, we're getting there. Ignoring return values. So a function can return a value that the caller doesn't care about. A function can return a value that the caller doesn't care about. We can explicitly ignore variables using an underscore. Or more precisely, the blank identifier. For example, ignore y value. Even though getPoint returns two values, we can capture the first one and ignore the second. In Go, the blank identifier isn't just a convention, it's a real language feature that completely discards the value. Why might you ignore return value? Maybe a function called getCircle returns the center point and the radius, but you only need the radius for your calculation. In that case, you could ignore the center point variable. The Go compiler will throw an error if you have an unused variable declaration in your code, so you need to ignore anything you don't intend to use. So run the code as is, you should get a compile error. Fix the get product message to ignore the unused return thing. So quantity, price messaging, description. Yay! Name return values. So return values may be given names, and if they are, then they are treated the same as if they were new variables defined at the top of the function. Named return values are best thought of as a way to document the purpose of the return values. According to the Tour of Go, a return statement without arguments returns the named return values. This is known as a naked return. Naked return statements should be used only in short functions. They can harm readability in longer functions. Use naked returns if it's obvious what the purpose of the return value is. Otherwise, use named returns for clarity. So x and y initialize with 0, automatically returns x and y is the same as var x and y, return x and y. In the first example, x and y are the return values. At the end of the function, we could simply write return to return the values of those two variables rather than returning x and y. Assignment. One of our clients likes us to send text messages reminding users of life events coming up. Fix the bug by using named returns in the function signature. The variables need to be automatically initialized. Order them as they appear in the code. Do not alter the body of the function. So I guess they're all going to be in, so you could do years until oh, I killed something. There we go. The benefits of named returns. So for good for documentation understanding. So named return parameters are great for documenting a function. We know what the function is, returning directly from its signature, no need for a comment. Named return parameters are particularly important in longer functions with many return values, which is easier to understand than this. Yeah, way better. We know the meaning of each return value just by looking at the function signature. So func calculator, a, b, in, yep. Nil is the zero value of an error. More on this later. Okay. Less code sometimes. So if there are multiple return statements in a function, you don't need to write all return values each time, though you probably should. When you choose to omit return values, it's called a naked return. Naked returns should only be used in short and simple functions. Choose to omit return values. When might you use naked returns for small functions? When should named returns be used? When there are many values being returned, when there are a few parameters being returned, when the function is simple. Many values being returned. Explicit returns. So even though a function has named return variables, we can still explicitly return values if we want to. So this is explicit. Using this explicit pattern, using this explicit pattern, we can even overwrite the return values. This is explicit x and y are not returned. Otherwise, if we want to return the values defined in the function signature, we can just use a naked return or a blank return. Assignment: fix the bug in the code so it returns the named values explicitly. Yay! Early return. So Go supports the ability to return early in a function. This is a powerful feature that can clean up code, and especially when used as guard clauses. Guard clauses leverage the ability to return early from a function or continue through a loop to make nested conditionals one-dimensional. Instead of using if-else change, we just return early from a function at the end of each conditional block. So error handling in Go naturally encourages developers to make use of guard clauses. When I started writing more JavaScript, I was disappointed to see how many nested conditionals existed in the code I was working on. Let's take a look at an exaggerated example of nested conditional logic. Yeah. This could be written with guard clauses instead. Yep. The example above is much easier to read and understand. When writing the code, it's important to try and reduce the cognitive load on the reader by reducing the number of entities they need to think about at any given time. In the first example, if the developer is trying to figure out when 270 is returned, they need to think about each branch in the logic tree and try and remember which cases matter and which cases don't. With one-dimensional structure offered by guard clauses, it's as simple as stepping through each case in order. Which is true. Guard clauses provide a linear approach to logic trees. Guard clauses are unreadable. Guard clauses are generally worse than what is a guard clause? So an early return from a function when given a condition is met. An AND operator in a Boolean logic, a bitwise OR operator. Early return. So functions as values. Go supports first class. Read what the first class means. So first class function. A programming language is said to have first class functions when functions in that language are treated like any other variable. For example, in such a language, a function can be passed as an argument to other functions, can be returned by other functions, and can be assigned as a value to a variable. So it goes to blah, 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 which are just fancy ways of saying functions as values. Functions are just another type, like ints and strings and bools. let's assume we have two simple functions. Func add, func multiply. We can create a new aggregate function that accepts a function as its fourth argument. Excuse me. So it calls the given the given arithmetic function, which could be add or mul, or any other function that accepts two ints and returns int and applies it to 3 inputs instead of 2. It can be used like this. Some aggregate like that. Assignment. Complete the reformat function. It takes a message string and a formatter function as input. Apply the given formatter 3 times to the message. Add a prefix textio to the result. Okay, result is a walrus equals, it's going to be formatter, message, add a prefix to the result. So result, and then return. So it's going to be a text IO result. So first, second, result. So first, second, result. So passed. This will pass, but I want to see if there's a more elegant solution where they just do it in one line. Oh, once, twice, thrice, prefix. Okay, right, they just do it in the same way. Nothing, no magical sort of shorting of things and stuff like that. That's fine. So anonymous functions. Anonymous functions are true to form in that they have no name. They're useful when defining a function that will only be used once or to create a quick closure. So closure, so in programming languages, a closure, also lexical closure or function closure, is a technique for implementing lexically scoped name binding in a language of first-class functions. Operationally, a closure is a record storing a function together with an environment. The environment mapping is associating each free variable to the function. Variables that are used locally but defined in enclosing scope with the value or reference to which the name was bound when the closure was created. Unlike a plain function, a closure allows the function to access those captured variables through the closure's copies of their values or references, even if the function invoked that is outside their scope. So anonymous functions. So anonymous functions are true to form in that they have no name. They're useful when defining a function that will only be used once or to create a quick closure. Let's say we have a function, conversations, that accepts another function, converter, as the input. We could define a function normally, then pass it in by name, but it's usually easier to just define it anonymously. Yeah, okay. Makes sense? Assignment. Complete the print reports function. It takes as it takes as input a sequence of messages, intro, body, outro. It should call print cost report once for each message. So I guess we just run print cost report. And what was it, like the cost calculator function, and then message. All right, okay, right, yeah, I got you. So it's going to be func, no name. It's going to be intro string int, and then it's going to be, I guess, length of intro. Intro length, so return times 2. I know these don't have to say the same thing, but I'll just do it for simplicity's sake. Right. Here. Defer. So the defer keyword is a fairly unique feature in Go. It allows a function to be executed automatically just before its enclosing function returns. The deferred call's arguments are evaluated immediately. But the function call is not executed until the surrounding function returns. Deferred functions are typically used to clean up resources that are no longer being used, often to close database connections, file handlers, and the like. For example, so get username. So create a connection, open a database, close the connection anywhere the get username function returns. Connection. Okay. Blah blah blah. The defer statement is also executed if we return here. Defer statement is also executed if we return here. In the example above, the con.close function is not called here. Defer, it's called here or here, depending on whether the fetch user function errored. We'll cover errors later. Defer is a great way to make sure that something happens before a function exits, even if there are multiple return statements, a common occurrence in Go. So assignment, complete the boot up function. Notice it potentially returns in 3 places. No matter where it returns, it should print the following message before it returns. Use defer so that if you have to write this message once, the message should be printed on its own. Message should be printed on its own new line. Okay, so defer, and then fnt dot print ln. I think that's it. Oh, fmt. Whoops. fmt. Happy days. Block scope. So unlike Python, Go is not function scoped. It's block scoped. Variables declared inside a block are only accessible within that block, and it's nested blocks. There's also the package scope. We'll talk about packages later, but for now you can think of it as the outermost nearly global scope. So scope to the entire main package, basically global. Scope to the send message function. Scope to the for loop. Blocks are defined by curly braces. New blocks are created for functions, loops, if statements, switch statements, select statements, and explicit blocks. If it's a bit unusual, but occasionally you'll see a plain old explicit block. It exists for no other reason than to create a new scope. Okay. Run the code without changing anything. You should see a compilation error. I do. Fixing the scope issue in the function so it returns as you expect. Explicit blocks. Okay. Processing orders. So management thinks our branding is so creative that our SaaS customers will pay for Textio merch. Complete the place order function. It returns a bool indicating the order was successful. True is a success, and a float 64 representing the user's balance after the order. The place order function should always return the account balance regardless of if it was adjusted or not. The amount in stock and call price functions can be used to look up the current stock and the price of an item. So complete that. Returns bill indicating whether the order is successful, true, and a float 64 representing the user's balance after the order. The place order function should always return the account balance regardless if it was adjusted or not. Can we use blah blah blah? If the quantity, here we go. So if the quantity is greater than the amount in stock, the order should be rejected. So if the quantity is greater than the amount of stock. Oops. Amount in stock, product ID. Amount in stock, products ID. Then should be rejected. So I guess return false. And the account balance. If the user doesn't have enough money in their account, the order should be rejected. So if the user doesn't have enough money in their account, so if the account balance is less than, they calculate the price and you give it the product ID and quantity, then return false and the account balance. Otherwise, the order should be accepted and you should return the new balance. So I guess return true and calculate price list. Find stock. I guess account balance minus calculated price, like that. Yay. We're getting low on battery, so let's just pop the thing on. Huzzah! That's simple enough. Closures. So a closure is a function that references variables from outside its own function body. The function may access and assign to the reference variables. In this example, the concata function returns a function that has a function in this example, the concata function returns a function that has a reference to an enclosed doc value. Each successive call to Harry Potter aggregator mutates that same doc variable. Returns a function that has a reference to an enclosed doc value. Each successive call to Harry Potter aggregator mutates the same doc variable. Okay. Oof. Assignment: keep track of how many texts we send. Keeping track of how many texts we send is mission critical for Textio. Complete the adder enclosing function. It should return a function that adds its inputs and int to an enclosed sum value, then return the new sum. In other words, it keeps a running total of the sum variable with a closure. So say sum is a walrus 0, and then return a function that takes takes an input or like it should return a function that adds its input to its enclosed sum value. So input, just an int, returns an int. It's going to be basically return sum plus inputs. Whoops. Return sum. Easy. Currying. Oh, I never liked currying in JavaScript as well. Function currying is a concept from functional programming and involves partial application of functions. It allows a function with multiple arguments to be transformed into a sequence of functions, each taking a single argument. Let's simulate this. Let's simulate this behavior. For example, square func self mash multiply blah 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 multiply. In the example above, self math function takes in a function as its parameter and returns a function that itself returns the value of running that input function on its parameter. Okay, assignment. The Textio API needs a very robust error logging system so we can see when things are going awry in the back-end system. We need a function that can create a custom logger, a function that prints to the console given a specific format. Complete the getLogger function. It should take as input a formatter function and return a new function. The logger function takes as inputs 2 strings and passes them to the formatter, then prints the result. Keep the order of the strings. So getLogger takes a function that formats 2 strings into a single string and returns a function that formats 2 strings but prints the result instead of returning it. So it goes to return. getLogger takes a function that formats 2 strings into a singular string and returns a function that formats 2 strings but prints the result instead of returning it. It should take as input a formatter function and return a new function. The new logger function takes. Okay. Params takes so it should take as input formatter function that return a new function. The new logger function takes 2 input strings, so it's going to be first and second strings and passes them to a formatter function, then prints the result. First and second. this right? And return a new function. The logger function takes two inputs, and pass them to format and then prints the result. Huh. That wasn't the most clear instructions, but never mind. A little bit confusing in a sense. How long we got? Got about roughly an hour. Okay, so structs in Go. We use structs in Go to represent structured data. It's often convenient to group different types of variables together. For example, if we want to represent a car, we could do the following. Type car struct brand is a string and model is a string, doors is an integer, miles is an integer. This creates a new struct type called car. All cars have brand, model, doors, and mileage. Structs in Go are often used to represent data that you might use a dictionary or object for in other languages. So assignment, complete the definition of message to send. Struct needs two fields, phone number, phone number, int, nope, let's keep doing that, and message, int, nope. Okay. Oh, string, whoopsie daisy. Easy. Nested structs in Go. Structs can be nested to represent more complex entities. So the fields of a struct can be accessed using the dot operator. Assignment. Textio has a bug. We've been sending texts that are missing critical bits of information. Before we send text message to Textio, we must check to make sure the required fields have non-zero values. Always send text message to Textio. We must check to make sure the required fields have non-zero values. Notice that the user struct is a nested struct with message to send with the message to send struct. Is a nested. Oh, within the other one, right. Both sender and recipient are user struct types. Complete the can send message function. It should return true only if the sender and the recipient fields each contain a name and a number. If any of the default zero values are present, return false instead. So I guess if to send message to send, so I guess if to send dot sender and what we're checking should return true only if the sender and recipient fields contain a name and a number. If any of the default zero values are present, return false instead. So sender dot name is equal to like blank, I guess, or I have to do pipes Perhaps, or m to send dot sender the dot number is equal to 0, or, and then I guess like it's just return false. And m to send dot recipient dot name is equal to blank, or m to send dot recipient dot number is equal to 0. Might be a more elegant way of doing this. Looks like I might have to refresh. It's kind of goofing up a little bit. Can't have triple equals. Is that the problem? Looks like it might be. Empty rune. Don't know if it makes a difference. Okay, not triple equals. I guess it just could be or as well, like or that. Yep. What do they put there for their solution? Oh. Yeah, okay, to be fair. Yeah, it kind of splits it down a little bit. So anonymous structs in Go. So an anonymous struct is just like a normal struct, but it's defined without a name and therefore cannot be referenced elsewhere in the code. To create an anonymous struct, just instantiate the instance immediately using a second pair of brackets after declaring the type. So you can even nest anonymous structs as fields within other structs. So type car struct, blah blah blah, wheel struct. Wheel is a field containing an anonymous struct. Yep, so you can't use like wheel out of context and stuff. When should you use an anonymous struct? In general, prefer name structs. Name structs make it easier to read and understand your code, and they have a nice side effect of being reusable. Sometimes I sometimes use anonymous structs when I know I won't ever need to use a struct again. For example, sometimes I'll use one to create create the shape of some JSON data in HTTP handlers. If a struct is only meant to be used once, then it makes sense to declare it in such a way that developers down the road won't be tempted to accidentally use it again. You can read more about anonymous structs here if you're curious. What is a good reason to use an anonymous struct? You're worried about user privacy, you're worried about security, you need your code to be faster. It is only being used once. What's one advantage of using anonymous structs? Anonymous structs prevent you from reusing a struct definition you never intended to reuse. Anonymous structs make your code run faster, blah blah blah. First one. Reusing things you shouldn't do. Embedded structs. Go is not a object-oriented language. However, embedded structs provide a kind of data-only inheritance that can be useful at times. Keep in mind, Go doesn't support classes or inheritance in the complete sense, but embedded structs are a way to elevate and share fields between struct definitions. So type car struct, blah blah blah, type truck struct. Car is embedded, so the definition of a truck now also additionally contains all of the fields of the car struct. Embedded versus nested. So unlike nested structs, an embedded structs fields are accessed at the top level like normal fields. Like nested structs, you assign the promoted fields with the embedded struct in a composite literal. Unlike nested structs and embedded structs, fields are accessible at the top level like normal fields. Like nested structs, you assign the promoted fields with the embedded struct in a composite literal. It's a composite literal. Composite literals construct new values for struct arrays, blah, 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 and be evaluated. They consist of the type of literal followed by brace, blah, 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 blah. Okay, decorations, one may write array. Range truck. Brand. Oh, I see. Right, okay. I get you. Okay. Yep. In the example above, you can see that both brand and model are accessible at the top level, while the nested equivalent to this object will require you to access the fields via a nested car struct, like that. Assignment. In Textio, a user struct represents an account holder, and a sender is just a user with some additional sender-specific data. A sender is a user that has a rate limit field that tells us how many messages they are allowed to send. Fix the bug by embedding the proper struct in the other. So sender is just type of user. Keep getting my shortcuts mixed up. Struct methods in Go. So while Go is not object-oriented, it does support methods that can be defined on structs. Methods are just functions that have a receiver. A receiver is a special parameter that syntactically goes before the name of the function. So area has a receiver of rect. Rect is the struct. R is the placeholder. Yeah. Okay. Okay. Makes sense. A receiver is just a special kind of function parameter. In the example above, the R in rect Could just as easily have been rec or even X, Y, or Z by convention. Go code will often use the first letter of the struct's name. Receivers are important because they will, as you'll learn in the exercises come, allow us to define interfaces that our structs and other types can implement. Assignment. Let's clean up Textio's authentication logic. We store the user's authentication data inside an authentication info struct. We need a method that can take that data and return a basic authorization string. The format of the string should be this. Create a method in the authentication info struct called getBasicAuth and that returns the formatted string. So okay, so we're going to say func, and then we're going to pass auth as the authentication info, and this thing is going to be called I'm going to call it this. All right. Yeah. Get basic auth in. It's not going to take anything, but it's going to return a string. And it's going to return fmt dot sprintf, and it's going to be I guess a dot username, and then a dot password. So this is going to be percentage string, and I guess percentage string as well, and see what it does. Oh, I suppose we don't need that, do we? Just return it. Oh no. It's printf. Forgotten how it goes. Is it import fmt from fmt? Is it like that? Yes. Let's have a look at the solution. Is it much different? Nope. Why didn't they have to? Oh, they just literally just concatenate it. Duh. Okay. Yep. Remember that. Memory layout. So in Go, structs sit in memory in a contiguous block with fields placed one after another as defined in the struct. For example, this struct type stats struct reach number of posts and number of likes looks like this in memory. So reach total 4 bytes. Okay, yep, 16. Field ordering matters. In the order of fields in a struct can have a big impact on memory usage. This is the same struct as above, but poorly designed. So it looks like this in memory. Notice that Go has aligned the fields, meaning that it has added some padding, wasted space, to make up for the size difference between uint 16 and uint 8 types. It's done for execution speed, but it can lead to increased memory usage. Should I panic? To be honest, you should not stress about memory layout. However, if you have specific reason to be concerned about memory usage, aligning the fields by size, largest to smallest, can help. You can also use reflect package to debug the memory layout of a struct. Real story. I once had a server production that held a lot of structs in memory, like hundreds of thousands in a list. When I reordered the fields in a struct, the memory usage of the program dropped over 2 gigabytes. It was a huge performance win. Wowee, that is a crazy story. A Assignment. Our over-engineering boss is at it again. He's heard about memory layout and wants to squeeze every last byte out of our structs. Run the test to see the current size of the structs and update the struct definitions to minimize the memory usage. Expecting actual, okay. So move that up. Bingo, where's his name? Oh. Empty struct. So empty structs are used in Go as unary value. Unary value. In mathematics, a unary operation is an operation with only one operand, a single input. This is in contrast to binary operations, which use two operands. Example is an any function. So, okay. Anonymous empty struct type. Named empty struct type. The cool thing about empty structs is that they're the smallest possible type in Go. They take up 0 bytes of memory. Okay. Later in this course, you'll see how and when they're used. It's surprisingly often, mostly with maps and channels. Okay. Why does the empty anonymous struct have two pairs of braces structured there? It doesn't. It's a syntax error because Go developers like to flex their 200 words per minute typing speed. Struct is the type empty struct and is the value empty struct literal. Yeah. Which is ordered from least to most memory usage? Least to most. Oh, right. Okay, I see. That one. Update users. So we need a way to differentiate between standard and premium users. When a new user is created, they need a membership type, and that type will determine the message character limit. Create a new struct called membership. It should have a type. Okay, so type membership struct, and it should have a type. A string field, so type string field, a message character limit integer. Okay, I'm just going to copy that because I'm lazy. Integer field. Nope. Okay. Update user struct to embed a membership. So I guess it's just going to be membership. Complete the new user function. It should return a new user with all the fields set as you would expect based on the inputs. If the user is a premium member, the message character limit should be 1,000, otherwise should be 100. So I guess return a how would you put it? Oh, right, okay. I just completely forgot the syntax for some reason, like how to... Whoopsie daisy. So I guess return user. So type is, I've forgotten the syntax like already. Hold on. I don't know why I've just like the syntax now is like just kind of falling out of my head. Like, yeah, I don't know why I was doubting myself there. So type would be membership type, and then name is name. Suppose message. I guess if membership type is equal to premium, then message character limit is equal to 1000. Does that run? Nope, got it completely goosed up. So just a declare not use message character limit. Go return struct. Am I just getting the wrong syntax? But not use message char limit. Team arguments and conversion for user. Too many arguments in conversion to user. Got my thing wrong, so syntax is wrong. Okay, and then name. Better not used. Whoops. Silly me. What? New passion. I'm struggling with this basic one. You can't use membership type variable string as membership value in struct literal. Why not? Can't use char limit as string value in struct literal. String. What would you wrong here? Ah, so that's boots. Oh, what am I doing wrong here? How are the fields being matched to the struct fields? Are you relying on field order or naming them? Field order. Char limit. Yeah. Given that, what type does the first field of user expect? Membership type. Where are you passing there? Similarly, inside membership, which field expects a string and which expects an int? How could you ensure that each value is assigned to the correct one? Try rewriting the struct literal so it's explicitly set by name. Also consider reconstructing embedded measure, then place it into the user. Which changes would that imply? Just do it like that. So like that. Name. Is this better? Whoops. In a user literal, you can set type message directly, or do those along the embedded, membership value. How can you create a membership struct with type? You set type directly, or can you set or do those belong to the embedded membership value? How could you create a membership struct with type in message set that can and then place that into user under its embedded field? What would a user literally specify? Okay. Try build membership value first and return a user with membership. What? Unknown field type instruct literal of type user. I'm confused. When you embedded struct, remember, so the fields of the embedded struct become accessible directly on the outer struct. But how do you think you should initialize those embedded fields when creating user? Take a look at return statement. You're trying to set type and message character limit directly on user, but those fields actually belong to the embedded membership struct. Here's a hint. You need to create a membership value first and then embed it in the user. How might you construct the user struct to include both name and so just like struct membership like that. Oh, I don't know. It's gone completely out of my head. Nearly there. Oh, jeez. Gosh. Right. It's something I'm going to have to get used to a little bit. Okay, nested stuff. Right. Okay, gotcha. That really threw me through a loop syntactically wise. Didn't really understand what was wrong with that, but okay. I think we got it. So send message. So assignment, create a send message method for the user struct. It should take a message string. Create send message function. So send message. And it's going to be, what's the thing? So it's going to be user like that. Send message. Should take a message string, and message length is int inputs, and then message length is int. As inputs, if the message length is return the original message and true, so it's going to be otherwise return empty string and bool. So if message length is within the user's message character limit, so I guess if length of message is less than, I guess, or equal to message. Completely, and this is not very good. It's just the length. Then return message and true. Also return an empty string and false. See what it does. Not quite. Oh, comma between them, my fault. And here. Unexpected name bool after top level decoration. This. Unexpected comma after top level decoration. Line 3. Oops. So return. Yay. How's that? Oh, crap. Why not? Oh, hold on. So if the message length is within the user's message Oh, dum me. Whoopsie dum. Whoopsie dum dum. Yeah. Right. Forgot to invoke that. No? What? Thanks for doing this live. No worry about Simpson. Here to serve. Okay, if the message length is within the user's message character limit, swap that. So is less than is character limit that way around? No, what the heck? Less than or equal to, I guess. Okay, now finish. Boom. Okay, just totally messed up like what I was checking for. Right, it's 10:30. We got to chapter 5. I'm not going to be able to knock this out like tonight and stuff, so we're going to leave it there. But we do well. It means like tomorrow we get to 5, 6, 7, 8, 9, 10. Maybe it might be that we have to go for 4 sessions with this one. But good progress tonight so far, to be honest. So I'm going to leave it there for tonight. It's good progress. Thanks very much for coming along and watching. It was fun. I learned a lot already. I feel like I've already sort of like kind of built a little bit of muscle memory for like some basic syntax stuff. So yeah, thanks for coming down. Thanks for watching. If you've had fun, subscribe, like, join. Tomorrow we're going to be doing another session. If you're coming from the future, thanks for coming back and tell us where you got your time machine. Good night, and I'll see you tomorrow.